You working?
Oh, yeah, so I left my math stuff at home, so my mom's bringing it to me right now.
Yeah.
When she gets here, can I just like go get it?
Yeah.
Thank you.
That one. Okay, not starting these for 5-6 minutes because you're too busy looking at your phone is not a good way to get them done or have them accurate. So please get going. We're still going. Okay. Yes, Jacob, what was that?
What was it? Such a video of Emma, 2M.
I was more concerned that it looked like you were pointing it directly at me. In which case, you, me, skate park, after school.
After school. Yep. Always seen it.
Anyone still rolling? Okay. I'm going to take that vertex. Now I'm going to put it where? Left 1 up 4. So maybe I should write those two transformations. Stop that. Of a horizontal translation, left 1, and a vertical translation, up 4. Okay. Happy parabola or sad? It's a sad parabola. How do I say that in terms of a transformation? Reflect in the x-axis or vertical reflection. If you say reflect in the x-axis, you should say it first. If you say vertical reflection, you can say that at any point, because I can just reflect about the vertex instead of over the axis. Okay, and finally, what's that 1/2 do? Vertical compression by 1/2. So that means from this vertex, normally I would go over 1 and up 1, over 2 and up 4, over 3 and up 9, because those are perfect square steps. I'll take all of them times a negative 1/2. So it's not over 1 up 1, it's over 1 down 1/2, over 2 down 2, over 3 down 9 halves, over 4 down 16 halves, or 8. Over 5 down 25 halves, or 12.5. Mirror those across your axis of symmetry. Shoop, 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 and mix shoop. It was curvy, but I missed the dots. Oops. So, 5 things, 5 points. Did you do it? Did you do it? Did you do it? Did you do it? Is your graph right? Yeah, this is no V. This isn't absolute value. If it's going out that far, that means you screwed something up. Yeah, this is a slope, dude.
What's with it? It's supposed to be curved, my guy. A U.
Come on, meow. Any questions on this? Okay. Hearing no objections, the motion passes. Oh, I never even brought up our notes.
I could probably do it. I just don't know.
You ain't pre-coat. There we go. That's better. Don't. You saw it, right? It says, you haven't been here in a while. Would you like to stay logged in? Yes, I would like to stay logged in. No. All right. Were there any questions before I keep pressing buttons? Are you kidding me? I'm right here. All right, before I throw a chair through Frank's face, is there any questions from the homework? Damn. Okay. Hold on, let me just start from the beginning. Do I have to re-click? Like y'all seen that video clip, or it's a GIF, gal who keeps throwing popcorn at the guy, and he's yelling at her no, and then finally he just loses his crap and grabs a Christmas tree and just yeets her off the couch with it? No? Okay. I feel like doing that with Frank right now. Why aren't you doing anything? All right. That's what I mean.
It's a strong man.
Now that's the gift that usually gets around. The whole video, she's sitting here like dinking popcorn at him for like 2 minutes, and he's telling her to knock it off. I haven't actually had anyone make popcorn in here today, so I don't know what you're talking about. Okay, finally there. Took long enough. What was the question? For favor. 39. Okay. 39 words. Words. Okay. The equation for the cost in dollars producing computer chips is this, where that is the X is the number of chips produced. So X is how many chips you make. C is going to be the total cost. Find the number of chips that minimizes the cost. Okay. I leave this one in here to see who can figure it out, who remembers from Algebra 1. This isn't in Vertex form, is it? And if it's not in Vertex form, how am I going to find my minimum? Well, that's what we do today. We do standard form, which is what that is. But there was a calculator trick, if you remembered how. So, everyone got your calculator on hand? Badoop, badoop. Go. Second plus. Quit. Second plus 7. Okay. Go to y equals, and we're going to type in that function. We have 0.12340 zeros, 15x squared, minus 0.03x plus 35. Okay. Now, just looking at this before I do anything else, what would happen if I put a 0 in for x? No. 35. X equals 0 on the y-axis. Finding a y-intercept by putting a 0 in for x is a common algebraic theme. So I know that this is going to have a y-intercept at 35. Is it a happy parabola or a sad parabola? Okay, if I have a positive parabola and I know that it has a y-intercept of 35, I know that's the general shape of it. Whether it crosses the x-axis, I don't know. Because it's looking for a minimum, I'm guessing it's not going to cross the x-axis. Because you probably don't want a number of chips that minimizes the cost by actually making you money. Like, how can you make money if that's the cost? You make money when you sell them. It just doesn't make sense in the context of the problem. So I'm probably going to have a parabola that looks like this. So I can hope that my calculator will go find the relevant features for me by doing zoom fit. Zoom fit is supposed to say, the calculator looks at the function and says, well, it's a quadratic. Quadratics are going to have x and y intercepts, a maximum or a minimum. I should try to put those on the screen. So if my calculator is not dumb, I can hit zoom fit and it should show me my minimum, and it doesn't. Okay, so let's go to my window. Well, it only went out to an X value of 10. Are you going to make only 10 computer chips?
No,
Probably not.
I would like 100.
So maybe I'm going to make more like 1,000 chips. You're going to make money, right? Okay, I'm going to go from, oh, maybe I should go 0 to 35. Why are they only going from 34 to 35? That didn't make sense. So now I'll look at it. Ooh, I can almost see it. It's close. I see a little curve to it. I just got to take that X further out.
You put 10,000? Or 10,000?
I went out to 2,000 and cool, I can see my parabola. So if you can do zoom fit, sometimes it'll work. Not always, because the calculator thinks that some things are more important than others. Beyond that, sometimes you just got to monkey with the window until you can see the features. Now that I see the features, y'all remember where calculate was? Stat, calculate, all of our regression stuff? Well, those, I had to hit stat to get to this calculate menu, because this calculates from the table that I input. Where are all the buttons that have stuff to do with the graph? Top row. Do I see calculate anywhere in my graph buttons? If I hit this calculate, this calculate, look at the options.
Minimum, maximum.
Minimum. If I want to calculate the minimum, then just find the minimum. Now, what is it saying at the bottom? Left boundary. What do I do? Put blinky on the left. Put blinky somewhere on the left. Now you can just keep poking left or right to manually move it around, or you can just type like a number and it'll put it there. It's going to ask you for a guess. This is purely for guess and check. I don't care. Tell me the answer. Okay? Make sure that these two are pointing in at each other. Left boundary, right boundary. Make sure they're on the left and the right. Everyone, real quick, raise your left hand. Some of you had to think about that. Okay? But the guess doesn't matter. Just hit enter again, and it will calculate your minimum. Now, we've talked about this before. Why does it say 1,000.0002? Maybe I talked about it in here. I forget which class. Oh, okay. When I calculate this minimum, when I put blinky on these two spots, it actually takes those 2 points and it puts them into an algorithm. So sometimes there's just a teensy bit of round off error. Okay. Now on the Casios, I'm pretty sure you can just like poke minimum and it just tells you. You don't have to do any of this. Okay. It's pretty handy. But this is a feature that you can use for all of our parabolas to find your vertices. If you find your vertex by just calculate minimum or maximum, you will always have the minimum or maximum. Okay? So I was hoping someone would ask that. I had one person ask that, but not until this morning. Otherwise, I just would have sent out the quick video that's here's how you find it. Y'all, it gets better the more you ask. Yeah. So let's go back to today's. Clear. You know what? Y. What was today's? -1/2 x. What was it? X plus 1 squared plus 4? I think. Okay, zoom standard goes back to my normal 10 by 10 grid. Shoop. Now, if I have no idea how to find that vertex, I will, second, calculate. What did this one have?
A maximum.
So I'm going to do maximum. I want to show you what happens if I screw this up. See how it says left boundary? What if I just accidentally hit enter and I'm like, oh, well, that's okay. I'll just put the other one over here.
It'll be backwards.
Look at where those arrows are pointing.
Out.
That says, I want you to find the maximum in here. So when I try to calculate it, it says,
Error.
not just error, read what it says.
Check for valid bounds.
Your right boundary is less than your left boundary. It tells you what you did wrong. Okay? So I will second calculate a maximum. You don't have to physically move Blinky around. I can just say -5, bam, 3, bam. Okay? As long as they're pointing in, we're good. And thinking.
Boom.
You see how sometimes it'll have that itty bitty round off error. You got to be smarter than the calculator sometimes. In fact, you are now in the class where you start to find things in the graphing calculator that you have to know why it's doing that. You have to know why that isn't actually at -0.999998. It's at -1,4. You got to be smarter than the calculator. Okay? So, I was hoping someone would ask that. Besides that one, we got this whole vertex form thing down. Like, the transformations that we originally were freaking out about, are they just kind of same old, left, right, up, down, stretch, compress? Put your right foot in, put your left foot out. Like, it's the same thing every time. Get used to it. At the end of every chapter for the rest of the year, the last section is always transformations of the functions we just talked about. Which is nice because it's easy. We're going to end every chapter by, hey, all the stuff that you just did, can you move it around? Cool. Okay, so these transformations going to be pounded into your head about like y equals mx plus b did. All right. With that said, leading directly into number 1. Graphing calculator, what are the vertex, axis symmetry, maximum or minimum value, and the range of this thing that is not in vertex form? Where do I go? Go to y equals. Clear that out, typey. 2x squared plus 8x minus 2. Graph. Shoot. Ooh, close. I'll move my window just a little bit. It looked like it was at -10, but I'm just going to move down a little bit more just to be safe. There we go. And if I see a vertex, now I know how to find it. Second, calculate. What am I calculating? Minimum. Okay. Need to go left a lot more than that. I'm putting over at -5. I'm going to make my right boundary somewhere over there, maybe at 0. As long as those are pointing in at where the minimum exists, I don't care about that guess, just tell me the answer. Be smarter than the calculator. What is this? -2, -10. So, find the vertex. -2, -10. If I know what the vertex is, what's the axis of symmetry? x equals -2. Remember, it's always a line. Lines have equations. Okay. It asks, do you have a maximum or minimum value? Well, I got a minimum. I have a minimum of -10 at x is -2. You notice that it didn't ask for the domain this time? Because what is the domain of the parabola? All real numbers. But I do know the range now. What's the lowest the y's ever go? -10, right? That's my vertex. That's my minimum. So from -10 onward, we used to write it like this. I would like you to get used to writing it as -10 to infinity like this. Do you remember why I use the bracket? Bracket means it equals. Think of this like a number line. The or equal to, remember it was more ink here means more ink there. If this has a line, this will have a bracket. It equals -10 on to infinity. If you need to write that again, bracket means it equals, parenthesis means it does not equal, it can't touch that. You'll have your lower boundary and your upper boundary. Okay? That's how you do interval notation. I want you to get used to it because, you know, I get kids coming up to pre-calc and they swear they've never seen it before. Okay, so I'm going to start doing that a little more. So if for some reason there was a hole, okay, if there was a hole right here, scrap, there we go. Like this. Okay, if I saw that, now I would say that my range is -10 to infinity with a parenthesis, because it wouldn't touch -10. Okay. Okay. So there's all the stuff pressing buttons on a calculator. Can you do it solo? Smash those buttons. Hit that bell. Don't forget to sign up for Patreon.
Yes.
No, you're not.
There. Now I did.
Okay, watch. You just have to go like this. Wait, okay. Yes.
Let's go all the way back to the ancient magic.
Oh. Okay, it didn't do before. This is so. Why did I even ask for that? Ooh. I know you tell it. It's
Maximum.
Go!
Question on what this means.
What this means. Argument error means how you typed it in. Maybe use the minus sign instead of the negative, or the negative instead of minus. That's usually the most common error.
Okay. Negative? This is the right X thing, right? If I click this, isn't that how I do X? I think it is.
Pretty sure. Oh, no, use this button. I think what you're doing is trying to input X. No, maybe. It's been a long time since I used Casios. I think you can use both. They look different. Then use the one on the keyboard.
Oh, second.
Minus.
Then you have to find the maximum since it's inverted.
Oh, and then this is the draw.
No.
Oh, wait.
So you go like 2, 1.
I don't think that's right.
Well, I'm guessing you can second into your Zoom or your window.
Oh, I see. Out.
Zoom auto. See if that works. Okay, so that's like the Zoom fit on mine.
Okay.
Okay, so let's play around with those. Do second Zoom. Zoom box. I wonder if that's just your normal 10 by 10. Oh, no, that's just a box on an area. Try again. Zoom. Second Zoom.
Oh.
Here, do shift window. Just go back to a standard window of -10 to 10, -10 to 10. Because that's where most of our stuff is.
Is it just right here?
Yeah, your
Yeah, it gives my X.
yeah, but change it to like -10 to 10. Because that's just a standard window.
I edited it. So just.
You beats me. I haven't done this for 12 years.
I have no idea.
Window. Standard store recall. That's view the window. How do you change the window?
Oh, that's V window, so I can't edit it.
Zoe, you're the Casio goddess here. Come on, help us out. Okay, help her to get the right window on there. It's the same thing, just a newer model. It's like 83 versus 84. Okay.
That's the equation.
Ah.
Oh, sorry. There you go.
Okay. Be smarter than the calculator. -2/3, 7 1/3.
Oh, you don't like the decimals.
So call it -2/3 and 22/3.
That's right.
Yeah. I'm pretty sure because Chad had something with 7 1/3 before, so yeah.
Boy.
Yism?
So I got this. I'm just confused on like
Okay, you can't just trace and wiggle around. You have to actually calculate it. You can't eyeball it, right? So we're going to find a maximum.
That's what I did.
Blinky, oh, it was sitting at 0.68 something, so. Blinky somewhere over there, Blinky somewhere over here. Guess who cares? Tell me answer. Okay. So if we don't know what those are off the top of our head,
Well,
then
I just put that as 8/3. I don't know.
not 8/3,
Just
7 1/3.
Oh, I just turned it to.
But 7 1/3 is 22/3.
Yeah, I'm bad at math. It's okay.
No, you're not. You just forgot the ancient magic. 7 1/3. Because you have 7 whole groups of 3 is 21, plus 1 left over, 22/3.
So I don't know how, like, the maximum is. What would I put that?
So your maximum value is 22/3. It happens at negative 2/3.
So what would the y be?
Your vertex is this, negative 2/3, 22/3. It's just ugly. And if you don't know what these are off the top of your head, you can always go back to main screen and type negative point spam sixes. Say math, change that to a fraction.
And then, so the range, would it be the 22/3 too?
Well, that was a maximum, right?
Yeah.
So it's actually going to be from negative infinity up to 22/3. Right? Because the lowest it ever goes is negative infinity. The highest it ever goes is 22/3.
Oh, because it's maximum.
Yep. Okay. So we're just a little sketchy on calculators. What? What? Ew! No. Okay. I got the thing, right? Zoom standard, Zoom 6, goes to a normal 10 by 10 by 10 grid. Once I'm here, calculate what? Maximum value, somewhere between -3 and 6. I don't care as long as they're pointing in. Badoop. Badoop. What the crap is that? Okay. All right. Be smarter than the calculator. What is point crap ton of sixes? So I have a vertex at -2/3. And if you have forgotten the ancient magic, 7 1/3
3 times 7 plus 1
is 22/3. Don't you dare write that as a decimal, because if you wrote it as a decimal, you had to cut part off your answer off. There's your vertex. We don't go to decimal town in this house. Unless it's for real world context. Like if I go into Necht Home Center and I ask them, I need 22/3 feet of 2x6. Huh? But if I tell them, yo, just give me 7.5 feet. Okay. Like, you gotta work with what you got. Axis of symmetry. Axis of symmetry is always the line that goes through that vertex. Okay, so if that vertex is up here at -2/3, 22/3, the line that went through it is x equals -2/3. We said it was a maximum value of 22/3, and it happened at x is -2/3. The maximum value is 22/3. That's the highest that I'll ever have for an output. It just occurs at x is negative 2/3. Range. Remember, when I make these range in interval notation things, it's always lower boundary than upper boundary. What's the lowest that ever goes? Lies. What's the lowest that ever goes? Negative infinity. The highest that ever goes is 22/3. So, parenthesis bracket. There we go. From negative infinity up to 22/3 is my range. Remember, it's lower boundary than upper boundary. If it goes all the way down to negative infinity, it comes up from there to 22/3. Or you could say y is less than or equal to 22/3. Okay. Now, what happens in the before times when I did not have the graphing calculator? What happens when I'm in the middle of a test and the teacher takes them away?
Then you wouldn't do that.
What happens when you're in the middle of an ACT and your calculator craps out? What happens when you take the smarter balance and it decides when you get a calculator and it says you don't need one for this? Okay. We need to know how to find the axis of symmetry for real. Now, do y'all remember, we're going to get to it later, quadratic formula? Top row, fourth from the left. Yeah, there was some little song with it. Okay. The quadratic formula is created by completing the square on the general form of a quadratic. Do you remember solve by factoring, solve by complete the square, solve by graphing, solve by quadratic formula? We're going to review all of those. If I do that to the standard form, you will find out that the axis of symmetry is a particular value right there. X is negative b over 2a. Like, that needs to be in big honking neon letters. Your axis of symmetry is always x equals negative b over 2a when I have ax squared plus bx plus c equals either 0 or y. When I put it in descending order like this, x squared, then x, then constant, a, b, and c are the coefficients and constant, the numbers of that quadratic. So if I take this thing and put it here, and I take that thing and I put it there, alakazam, I got my axis symmetry. Okay? So go back to the one we just did. We said y is negative 3x squared plus what? Okay. So I would say x is negative b over 2a, and I would plug in with parentheses, b is a negative 4, a is a negative 3, negative, negative, positive, positive, negative, negative, reduce, negative 2/3. That was our axis of symmetry. X is negative 2/3, right? Some people prefer the calculator, some prefer just scratching it out a little bit. Okay, you need to know how to do both. This chapter is one of the few times where I am actually going to make you do it certain ways on certain problems. because the standard that I have to assess is student is able to solve quadratics and polynomials by multiple appropriate methods. So I have to assess the different methods. Okay. Now, we said if I know this line always goes through what feature? The vertex. You see this big honking mess right here? Your member function notation? If I had y equals 2x minus 1, I could say f of x is 2x minus 1. The function of x is to do this stuff with x. Replace x with number. So if I said the function of 5, it would mean everywhere there was an x, stick a 5. Sound familiar? Okay. So when they say the x part is this, because we just found it, what does this say? This is written in Mathese, but it says something very simple. Plug it in. The function of that. Put that number into the equation and see what comes out. If this gets me x, shove it in the equation and get y. Right? If you know an x, you can find a y. That's all this is. So this may be my vertex, and it looks really ugly. But right next to it, I hope you're talking to Jacob and not me. I hope that instead of vertex saying negative b over 2a and function of negative b over 2a, maybe we can instead say axis symmetry, plug x in. Right? Your axis symmetry always goes through your vertex. If I know x, I can plug it in and find y. So it's written in Mathese. Not everyone's able to read Mathese. Show it in practice. The graph of this. If we have the vertex, we're okay using perfect square steps. But you got to find the vertex first. So I start with x is negative b over 2a. What's in the b spot right now?
2.
Remember, it's bx. So the b is separate of x. It's what's in front of it. What's a?
1.
1. Negative 2 over 2. There you go. That's your axis of symmetry. Your axis of symmetry is now at x equals negative 1. If I want to know where it hits the vertex, well, I know the vertex is somewhere on this line, so I'm going to come back up here and say y is something squared plus 2 times something plus 3. That something is going to be a negative 1. Don't square like a freshman, please. What's a negative 1 squared? And why is it telling me negative 1?
Because there's no parentheses.
Parentheses, okay? Parentheses are important. Parentheses keep us from screwing up exponents and signs. Okay? So this is a 1 minus 2 plus 3 is negative 1 plus 3 is 2. So that means I have a vertex now at, where'd you go? Come on. Negative 1, 2. Will this be a maximum or a minimum? How do I know?
It'll be a minimum.
How do I know?
It's not reflected in that.
The A value is positive. Happy parabola. What is, we said A is 1. Is there a stretch or compression?
Stretch.
If A is 1.
Oh, stretch. No.
Nothing, right? There is no stretch or compression. 1 is 1. So now just use your perfect square steps to finish off the graph. So from here, over 1, up 1. Stop that. Over 1, up 1. Over 2, up 4. Over 3, up 9. And we're just a little off-road. Mirror them across your axis of symmetry. Connect the dots. Try to keep it curvy. Okay. So you find your axis of symmetry. Whatever that number is, that's the x part of the coordinate. Plug it in, find the y. Once you got your vertex, just use your perfect square steps to finish it off. Okay? So instead of being in vertex form where they just straight up told us where the vertex is, now you got to find it. Same thing. You can do it on the same graph. There's room. Var be room. I don't know why you're whispering. Just talk.
Oh, that is not a pretty number.
They might be ugly.
I do need it to a fraction.
All he was saying was that you laid it on.
My vision.
Plus that. Plus 2.
Be not afraid of the fraction. Yo.
I accidentally did +3 from up there instead of -5.
Oh, you got it. Hi.
Which one do we use for the squares? Do we do times?
Your A value is still your A value. -2.
Oh, I see.
Yep. In fact, when we review complete the square, you'll see that A is the same whether it's standard or vertex form. What's B? 2. A. -2 over -4 is a 1/2. So when I plug 1/2 in, no, -B over 2A. A is already negative. Negative over negative is positive. So here I get, y'all know when you square a fraction, you square both parts. So 1/2 squared is 1 squared over 2 squared. 1/4. 1/4 times -2 is a -1/2. 2 times 1/2 is uno, -5. -1/2 plus 1 is 1/2. 1/2 minus 5 is -4 1/2 or -9 halves. Okay? Is there anything to say that you can't do that on a calculator? Is there anything wrong with setting up a fraction and saying, I don't feel like thinking right now? Saying -(2) over 2a, like that. And saying, you know what, I don't even want to type that anymore. I'm just feeling lazy. So I'm going to say -2 parenthesis, I'm going to put my answer that I just got in and square it, plus 2 times my answer that I just got. Oh. And then, what was it, plus 1? -5. Okay. Who says you have to think to do this? Let the calculator do the heavy lifting. Now, would I prefer that you knew how to fraction because you passed elementary school? Yes. Would I prefer that you didn't forget everything you knew about fractions in middle school when they allowed you to start using a calculator? Yes. Do I care if you do it either way? Nah. Okay. Now, we have a vertex at 1/2. You know what? I'm going to zoom in on this. You, get over here. If I have a vertex at 1/2 -9 halves, so I go over half a box, I go down 1, 2, 3, 4, 5, 6, 7, 8, 9 halves. If I do my perfect square steps from here, it's just going to be in the same location. Okay. So normally I would go over 1, up 1. Now I'm going to do what?
Over 1,
Down 2, because it's twice as far and it's reflected. So from here, over 1, down 1, 2. Over 2, down, not 4, 1, 2, 3, 4, 5, 6, 7, 8. So way down there. If my axis of symmetry is right here, I'm going to mirror across that. You see all your points end up just in the middle of the boxes. Okay? You still do the perfect squares, they just end up in the middle of boxes. So it's going to be way down here. Now, personally, I'm not a fan of only having 3 points and just trying to wing it like this. Show you a nice little trick with this. I think we did the same thing earlier. What if I just cheated and said by 2? Now, I got to be careful about where I put my vertex. Over a half down 4.5. Well, this is 2. This is 4. This is 5. My vertex is right here. In between. 4.5. But now when I do my perfect square steps, because my scale is twice as big, it will match my stretch. So over 1 box, down 1 box. Over 2 boxes, down 1, 2, 3, 4 boxes. Over 3 boxes, down 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. It just allows me to put more points on here to make my graph a little more accurate. In fact, if you change your Y scale to match your vertical stretch or compression, you will make the same graph every time. It's handy. We use that concept a lot in pre-calc when we do trig functions. So we need some practice with that. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We'll just say 20 is me. 15. 10, 11, 12, 13, 14, 15. Dawson. Which one do I have to do? Which one do I have to do?
22 for sure.
Okay. Dawson's over here like,
I was
no! Okay. If we say x is negative b over 2a. What is b?
6.
A.
Before negative.
Negative over negative cancels. I'll have a 6 over 2 times negative 3/4 is negative 3/2. Dividing by fractions is easy as pie. Oh, missed my negative. God.
Let's go.
Yup.
Yep.
Okay. Cancel, cancel.
On for the day, baby.
And then, if I take 6 times 2/3, 3 and 6 cross cancel. So it actually starts out like, there's fractions, but my axis of symmetry is just 4. But then I got to see, when I plug that 4 in, what do we got? Well, negative 3/4 by a thing squared plus 6 by a thing plus 6. If I jam a 4 in here, what's 4 squared?
16.
3/4 of 16. 12. So here I get a negative 12 plus 24 plus 6, which is 18. So it turns out my vertex is just at 418. I only got 10 boxes to the north. So if I want to fit them, I got to go by 2. Now's where it gets tough. Because even though I might be able to fit my vertex nice, over 4 up 18, I didn't change my x-axis. You don't have to change them at the same time. right? You've all seen that just on a regular graph in science, right? The x scale may be going by 0.1, but the y scale is going by 2 million or whatever. I don't know, bacteria colonies or something. Happy parabola or sad? Sad. And everything's going to get times 3/4. Now, not everyone is going to be a fan of that. Over 1 down, not 1, 3/4. But I got to remember, but if I did the scale by 3/4, would I be able to get up to 18? Ew. Okay, so I got to remember that if this is going by 2s, life hack, instead of staring at it like this, you see why I'm doing it? If I'm going by 2s, then each of these little tick marks is going to represent 1. So I'll remember if I'm going over 1 and down 3/4, I'll go 3/4 of the way to that mark. If I go over 2, normally I go down 4. Here I will do 3/4 of that. What's 3/4 of 4? 3. So I'll go over 2, down 1, 2, 3. I will go over 3, down, not 9. What's 9 times 3/4? Come. 9 times 3/4 is 27/4, which is 6 3/4. So over 3 down 2, 4, 6 3/4. Ew, this is really nasty, right? But I want to pay attention to these numbers, though. Here I went right 2 and I went down 3 instead of nasty fractions. If I go right 4, normally I move 16. 16 times 3/4. 12. What's a quarter of 16? 4 times 3. Take them in pieces. So I'll go over 4, down 2, 4, 6, 8, 10, 12. This was right 4, down 12. This was nice. This wasn't fractions. What do 2, 4 and 4, 16 have in common that might make this beneficial? Divisible by 4. Don't pick perfect squares that are ugly. Pick perfect squares that are divisible by 4, since I have to do something quarters. Okay? Don't do all of them, because not everyone wants all of these nasty fractions. Instead, is 1 divisible by 4? Don't do it. 2, 4. Is 4 divisible by 4? Yeah. What's 3/4 of 4? 3. So we'll go over 2, down 3. Is 3, 9. Is 9 divisible by 4? No. Don't do it. 4, 16. Yes. So I'll go over 4, down 12. 2, 4, 6, 8, 10, 12. 5, 25. 25 isn't divisible by 4. Don't use it. But 6, 36, that is. So I'll go over 1, 2, 3, 4, 5, 6, down, not 36. What's 3/4 of 36? 27. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 27. I still have enough points to see the curvature. I'll mirror them across my axis of symmetry. If this is 2 to the right, go 2 to the left. If this is 4 to the right, go 4 to the left. If this is 6 to the right, go 6 to the left. And on and on and on. I could keep going. I could go over 8 down, not 64, 3/4, 16, 48. Oh yeah, I still don't have room for that. So you picked a good one. And it wasn't about making the vertex either. Making the vertex did not make this difficult. Having to combine a 3/4 compression with a ×2 scale is what made it difficult. Okay, we're not doing Dawson again. 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Matthias, pick one. Which one do I have to do?
Do 20.
20? Okay.
24.
No, you changed your mind. Okay. X is negative b over 2a. Y is 1/2 something squared plus 2 by something minus 8. What is b? 2. What is a? 1/2. What is 2 times 1/2?
1/4.
What is 2 times 1/2?
1.
1/2 squared is 1/4. So I get negative 2 over 1 is just negative 2. Stick a negative 2 in there. Negative 2 squared is?
4.
4. Jeez. Vehement back there. What's 4 by 1/2?
I was thinking that.
That's 2.
All I was trying to say.
2 by negative 2 is negative 4 minus 8. 2 minus 4 minus 8 is? Negative 10. So I have a vertex at negative 2, negative 10. Happy parabola or sad parabola?
Happy.
So we have a vertex at negative 2, negative 10. So it's going to head upward, but I'm going to take all of my perfect squares and do what to them? Cut them in half. So if I go over 1, I don't come up 1. I go over 1 up 1/2. If I go over 2, I don't go up 4. 2. If I go over 3, I don't go up 9. 4.5. If I go over 4, I don't go up 16. Go up 8. If I go over 5, I don't go up 25. 25 halves, or 12.5. If I go over 6, I don't go up 36. I go up 18. Mirror them across your axis of symmetry. Connect the dots. Try not to suck. Actually, it wasn't terrible. I found I'm better if I don't look at the points. If I look ahead of the points and just let the hand move. Muscle memory. Now what I want to point out, some of those had halves. We were okay with it because we know halves. But could I have done over 2 up 2? Could I have done over 4 up 8? Could I have done over 6 up 18? I know those aren't the coordinates. I'm saying that's the movement. Because 2, 4, and 6 all have perfect squares that are divisible by 2, I should use those ones because they're easier to work with. That's what was tripping us up on the last one. Trying to deal with things that are divisible by 4. $18 and $20 are yours. Go.
At least you get
Don't be afraid of fractions.
You got it? Oh, come on. No, I'd be positive then.
Ooh, squishy.
Is that what you get?
I got 129, 8, 129,
No, I don't know why I got the house dirty. You're right.
We just put the same thing in each of our calculators and got 2 different answers.
They are literally the same.
No, they're not.
What's different?
Oh, you put this in there.
Negative is not minus. The negative button means times -1.
Did I actually put negative instead of minus?
The minus means add the opposite of.
Yeah, oh, you caught that. Okay.
They're different sizes.
Yeah, that's small.
Yep.
Okay, so.
Yo.
With this fraction,
So now we just.
would it be like go over 3, go down 4, or is it?
No, it's 3/4. So over 3 halves. 1/2, 2 halves, 3 halves. And then down 3/4. 1/4, 2/4, 3/4.
Yeah, it's a negative.
Now it shouldn't have been 3/4. -3/4 though.
9 times 3. Oh, no.
Negative 3, negative 1 is 3 has negative. Negative 3. Halves is negative 9 fourths plus 9 halves plus 6 is 18 fourths is positive 9 fourths plus 24 fourths is 33 fourths. Okay. I think you missed the negative on your original. Okay. Y'all, even if this is ugly right now, look at your A value. It's just a negative 1. So even if it starts in an ugly spot, back 3 halves up 33 quarters, which is 8 1/4.
Yeah.
So 8 1/4. Now just use your perfect square steps. 1, 1, 2, 4, 3, 9, 4, 16. 1, 2, 3, 4, 5, 6, 7. Mirror them across. Okay. Here's how it's going to work. Your assignment is just, hey, graph this stuff. That's it. It is just graph stuff. No application. The quiz tomorrow will have one of these on there, but it will not have nasty fractions. I want to do another day of practice before we do that. Oh.